In this video, we're going to be looking at logarithm, and we'll consider the meaning of logarithm. We will write logarithms in exponential form. We'll also write exponential equations in logarithm form, and then we'll evaluate logarithms. Okay, so we always have this kind of problem in math where we have to determine the exponent to which you must raise in order to get another number. An example would be, to what power must 2 be raised to get 8? All right, so for our purpose of discussion, we're going to create a play function called what power function. Okay, think about this function as taking in an input of 8, all right, and we're going to try to raise 2 to some number to get 8. Okay, so well, we can make it simpler if we try to write 8 as 2 to the power of something. Okay, so let's try to write 8 as 2 to the power of 2 to the power of 3, for example. Yeah, so rewriting that number there allows us to answer the question that to what power must 2 be raised to get 8? Well, we can see obviously that the power is obviously 3 there. So we can always answer that question by rewriting the expression or the number that's given to us. Okay, here are some other 3 problems for you to consider. So let's say I want to apply our play function. What power must 3 be raised to get 9? Well, you know, we can always raise 9 to the power of with a base of 3. We can raise to the power of 2, and so we can answer the question that the answer is 2. All right, so I want you to try to do those other 2 on the screen to see if you can do them by yourself. Okay, so now let's come back. We know that 36 will be 2 because 6 to the power of 2 is 36. Also, this must be 0. I hope you got that, because it was a little bit tricky, because 5 to the power of 0 is 1. So that's basically what we're going to be talking about. But in math, there's actually a function that is not just what power. That function is called logarithm. Okay, so logarithm is a function that is used to determine what exponent you must raise a number to get another number. So every time you see logarithm, think about it as what power. Okay, so I'm going to rewrite those questions. I have rewritten them, the same question we were answering on the previous page. To what power must 2 be raised to get 8? Now it's written in technical terminology, math terminology, as what is logarithm base 2 of 8? Okay, and actually the logarithm can be shortened to log. Most times you see in your textbooks log instead of logarithm. Okay, so now you can see the equivalence between our play function and the actual function that is mathematical. So we can see the correspondence. We have replaced the what power with log, and those are the answers we got on the previous page. Okay, so just a quick going over some of the other vocabulary you're going to see in this lesson. So whenever you see an expression like log base 2 of 8 equals 3, something like that, an equation, you would we can actually separate these numbers and call them different, to be able to refer to these numbers, we need to give them particular names. Okay, so this 2 is the base, and the 8 is called the argument, and the 3 is called the exponent. In other places, you might find that the 8 is referred to as the input of a function. If you think of logarithm as a function, that 8 will be the input, and the 3 here will be the output. Okay, so a logarithm expression or equation is basically asking you to what power must something be raised to get another number. Okay. All right. So here are three logarithm expressions on the screen for you. We're going to rewrite these expressions in the exponential form. So, well, we know that logarithm to base 4 of 2 is 1/2. Okay, what we'll do is we're going to write an expression with a base of 4. So it will be 4. This one becomes 4 to what power? 4 to what power? 4 to the power of 1/2 will give me 2. Okay? So 4 to what power? This is to what power we're talking about. Logarithm has something to what power. Okay, so 4 to the power of 1/2 will give me 2. Here's another equation. So 3 to what power will give me 27. 3 to what power? Okay, we know the answer. 3 to the power of 3 is 27. All right, in general, we can actually generalize this. K in this equation here, n equals log base k of m. We can say, well, k to what power will give me m. So we can go k to what power? Okay, k to what power? Well, the power is the logarithm. Remember that? That's the logarithm. Okay, k to the nth power should give me m. Okay, so on the left side, you will find logarithm equations, and on the right side, you will find exponential equations. So we can go from logarithm to exponential, or from exponential to logarithm. Here are some expression already in exponential form. We're trying to go from exponential this time to logarithm. So these equations can be written like, we're going to start, we're going to logarithm, so we'll start with log. We always start with log if we're going to log. Now, this number 7, we remember from the previous page, is actually the base. So we put the base. And remember, always, the one thing you need to know or be aware of all the time is that the exponent is the log. So that's the result. That's what we are going to raise 7 to get the input. So the answer is going to be that 2. That's the exponent to which we are raising 7. And then the result, the number that we're going to get is the 49. And that is the exponential form of that equation. All right, let's look at the next one. What is the base here? All right, we know we're going to go with log. Okay, what is the base? Of course, you know the base is 5. Okay, and we're going to be getting our answer equals 3. That's the exponent. And now we know that we are going to take the logarithm of 125 with a base of 5, and our answer should be 3. Okay, here is the last one. In general, when you see an expression like this or equation like this, what you would write is the log, and the base is obvious because it's the same base as what you're using for the exponent. So the base will be m, and the input will be p, and the answer is always the exponent. That's the answer. Okay, now we're going to use these ways of going back and forth to evaluate some logarithm. Okay, here are some logarithm. We're going to find their values. Okay, so logarithm says to what exponent or power must 2 be raised to get 1/2. Well, to make it easier for us, let's just call it x. Okay, we're going to call it x. Whatever that number might be, we're going to call it x. Okay, now let's apply what we learned in the previous page, that we can set up an exponential equation from this. So let's write an exponential equation using this. Well, let's do this, what my students call the cycle of power, or cycle of influence, or whatever. So we go 2 to what power will give me 1/2, or some people call it cycle of life. All right, so we say 2 to what power will give me 1/2. See, we have converted this expression, this equation, to an exponential equation. And from the previous lesson, we know how to solve this. So I'm not going to spend too much time explaining this equation because we already know how to solve this. So we go 2 to the power of x is 2 to the power of -1. And then we say x equals -1. So we are able actually to find the number to which we must raise 2 to get 1/2. We can test that it's true. Let's test it. We know that 2 to the power of -1 is actually 1/2 because, you know, the negative exponent says to do the reciprocal. So 1/2 equals 1/2, which is true. Okay, here is one more. To what exponent must 1/2 be raised to get 1/4? Okay, well, that's the meaning of log. All right, we say let it be x. Okay, now let's try to write an equation from here. Using the cycle of life again. So we do 1/2 to power of x equals 1/4. So 1/2, another color here, 1/2 to the power of x equals 1/4. So we know how to solve this equation because we've done it a whole lot. So we just need to make them the same base. This one is easy to do. So we just do 2 to the power of -1 to the power of x equals 2 to the power of -2. That's what we learned before. So now we can make one base out of this. 2 to the power of -x equals 2 to the power of -2. And so we can now make the, since the bases are the same, we just make the exponent the same. So -x equals -2. And then we can get x equals 2. This is actually can be tested. We can test it. So 1/2 to the power of 2. Well, if you apply the rule of exponent, 1 to the power of 2 is 1, and 2 to the power of 2 is 4, so which is true. Okay, this is really helpful that we're able to write any logarithm equation in terms of as an exponential equation. Here is another one. Okay, so this one is a little bit more complicated than the other ones, but it's the same principle. So we go, well, let's call this x, okay? And now we say, well, √2 to some power of x should give me 2. Okay, so we know we can write it √2 as 2 to the power of 1/2, because that's what square root does when you write it as exponent. We've done a whole lot of lesson on this already. So 2 to the power of 1/2 to the power of x equals 2 to the power of 1. And now we can just combine the exponent to over one base. So it will be 2 to the power of 1/2 x equals 2 to the power of 1. And now we're almost done. We just make the exponent the same. 1/2 x equals 1. And then we can solve this simple linear equation by multiplying both sides by 2. And then we're going to get x equals 2. Okay, so which is true, we can actually test it, because √2 squared will be 2, because √2 times √2 is just 2, is √4, which is just 2. So it's true. All right, let's try to do this other one. This one has a reciprocal. 1 over the square root of 2 equals, to what power will give me 32? All right, let's use another color over here. All right, so let's call it x. And then we go the same cycle of life. And then we try to write an equation out of that. So 1 over √2 to the power of x equals 32. And then let's finish it off by writing this as 2 to the power of negative, because of the reciprocal, -1/2. And then to the power of x, it will give me 2 to the power of 5. And now the bases are the same because 32 is 2 to the power of 5. Okay, so now we can just write -1/2 x equals 5. And then to finish this off, we can multiply all of these ones by -2. -2 and -2. So that on the left side, only x will be left. So we have x left alone. And then we have -10. We can test it. That's actually true. If you raise 1 over √2 to the power of -10, you get 32. Okay, so we're almost done. Here's one last thing to consider, that we need to illustrate. I need to illustrate that it is not possible to take the logarithm of 0 and negative number. We're going to see more about this when we graph, but let's use an example. So let's try to take the logarithm of 0 to the base of 2. All right, we're looking for some number x. Okay, let's try to do 2 to the power of x equals 0. 2 to the power of x equals 0. Well, we can try different numbers in the place of 0. Like trying to raise 2 to some number that will give me a 0. We discover that actually it is not, there's no such number. So this one does not exist. Does not exist. Okay, D-N-E. So it does not exist. The same way, if we try to call this one some number x and try to raise 2 to some number x, and to get -1, 2 to some number x to get -1, well, if you try, it's not possible. Either is, if you raise 2 to the power of -1, that would be 1/2. So there's no such number you can raise 2 to get -1. So this one is not possible. If you tried some other number like 2 to the power of, any other negative number you put in here, like you try to find a number to raise that to, it's not possible. So in general, it is not possible to take logarithm of 0 or negative or logarithms of negative numbers. So we can never take logarithm of any real number. Does that remind you of something that we learned before? You know that when we learn the function y equals, let's write down here, y equals the square root of x. If that is a function, the function we studied before, we know that that function does not accept all real numbers if we are in the domain of real numbers. So it does not accept negative numbers. It can take 0 though. So this one we say x has to be greater than or equal to 0. That's the domain for that. Okay. The same way y equals 1/x. We know that it does not accept all numbers because we can never divide by 0. So x is not equal to 0. That's the domain. It can take all numbers apart from 0. So if I give you now y equals logarithm of x, now we can make a general statement that, well, logarithm does not like negative number. You can never take negative number. You can't take 0. Then we can say, well, in this case, x has to be greater than 0. There'll be more of this when we do graphing in the next, in the future lesson. Well, until the next lesson, keep on getting high on math.